In this video, we're going to take a look at machining reliefs. And there's a specific tool for doing this called the machine relief toolpath. So if we go to toolpaths and then come down to 3D toolpaths, you can see that there's create machine relief toolpath. So if I click on that, it opens up the machine relief toolpath. Now, this is quite a straightforward toolpath, to be completely honest with you. What you need to do is select the area to machine. So just for the moment, I'm going to machine the whole of the relief. I'll just zoom out so we can see this. And what I'm going to do first of all is set up my material. Okay, so if I click to set up the material, now this gives me a material thickness of the model. Now, you're probably not going to get some material that's 0.57 inches thick. So what I'm going to do is, let's say my material is 3/4 of an inch thick. Okay. Now what this does, it sets up the material. Okay. Now bear in mind that my model is actually only 0.57 thick. Okay. Now the material Z0, set that up however your CNC needs to be set up. So if you zero on top of the material, you set it to the top. If you zero on the wasteboard or the spile board, set that to be at the bottom. Okay. So what I'm going to do is explain about this model positioning material, because for this toolpath, it is important. Okay. So at the moment, the model position is at the top, and it's got an offset at the bottom. So basically what this is doing, it's moving the very highest point of this model to be at the very top of my material, okay? And then I've got 0.179 of flat at the very bottom. So if I OK that, set up my material. Now if I rotate around, you can see that I've got this gap at the bottom. So that's telling me that there's going to be this much of a flat on the bottom. Okay, so if I were to set it up again, and then this time move it to be there, what would happen is that the bottom part of this model would move down to the bottom of the material. So it would skim off 0.179 at the very top of the material before it even started cutting this model. Okay, so if I rotate that around now, you can see it's got all of that fresh air that it's going to machine off of the material. Okay, now I'm going to set it up so it leaves it on the bottom, so it's a bit thicker. Okay, right, so I've got the whole relief to machine. Finishing options, so this is what's going to be actually creating the finishing cut. Now what you would use for this is a ball nose cutter. The reason being is that this generally gives a nice finish when it's going over the 3D contour, okay, because it's always going to that point. Okay, so if I select, let's say, I'll do something quite rough to start with. So if I select, let's say, 1/4 of an inch ball nose and select, and I'm just going to do this quite quickly to begin with, and then we'll take a look into the options. Okay, so if I were to calculate that now, then this generates the toolpath. So if I take a look here, zoom in, you can see the toolpath is following over the top of the contour. So if I were to simulate this now, you can see what's happening. So let's do a simulation control bar so we can see it, and press play. Okay, so this is going over and machining. So let's fast forward this a little bit. Okay, so that's giving me a representation of what's going to be cut. Now you can see that the 1/4 inch ball nose is machining all of this sidewall. So it's machining right down to the bottom in one pass because this is the finishing toolpath. So if I were to close this now, delete the simulation, what we can do, we can add a roughing option to this. Now you can also add multiple Z passes to this, so it doesn't do that whole of that sidewall, and you just use that 1/4 inch ball nose if you want to. But what I'm going to do is add a roughing tool to this. So if I click select, and then let's just use the largest tool that I have, which is a 1/2 inch end mill, and click select. Okay, and I'm not going to change any of the parameters for this, just select calculate. So what this will do, it will, rather than come across and follow the contour, this will slice the model up into sections and machine each section to rough it out. And it basically means less wear on your finishing tool. So if I were to simulate the roughing tool and press play, you can see that this goes round that chameleon and it leaves any area standing proud, okay, that it can't get in there to cut. And then if I do the finishing, then this only has a smaller amount to take off, so it saves a lot of wear and tear on the tool. So if I fast forward that so we can see what this looks like. Okay, so that's given me basically what I want. Now, there are a few things that you can tweak with this. So let's say if I were to zoom in, you can see, let's say here, then I've got all these cusps and I've also got them around here. Now, this is caused by the diameter of the tool. Okay, so what you would need to do to eliminate those is to use a smaller diameter tool. So if I were to use, let's say, let's see what else I've got, an 1/8 of an inch tool, we'll see what the difference is. So all that I'm going to do now is just simulate that 1/8 of an inch tool because I want to see where it's actually cutting over the top of this. So if I press play, you see how it's removing these cusps because it can actually get in there now. Okay, now it's still leaving some here. I can't do much about that. I'll just need to use a smaller tool if I want to remove them. Okay, so it'll be interesting to see what it looks like around this area here. Okay, so it is getting in there, but it still needs a smaller tool to actually get rid of all of those cusps in there. If you ever have marks around the edge, that's the reason. It's because the tool is just too large for it. So I'll show you the opposite way now. I'm going to use a 1/2 an inch ball nose. Okay, let's see what that does. So let's use the 1/2 an inch ball nose and calculate that. Now I'll just simulate this quite fast. Now I need to delete the simulation this time and then just right click and simulate the whole toolpath. Okay, so now you can see, because I'm using the larger tool, that it's leaving more of these cusps. Okay, so that's one thing to consider when you are machining these is A, the tool, and B, the step over of that tool. Okay, so let me go back to a 1/4 of an inch ball nose. And what I'm going to do with this is change the step over. So at the moment, the step over is 30 thou. Okay, let's make it 0.1 and calculate. Now, what this does is, because it's a ball nose, it only cuts on the tip of that ball. Okay, so if the step over is quite large, you will get cusps going over the model. Okay, so if I delete that, and then let's simulate the whole toolpath, you can see that I've got this stripy effect. Now, if you take a look at this, they're actually cusps going over the model. So it's basically the step over and the ball nose, the radius of the ball nose. Okay, so what you need to do is to make the step over a lot smaller. Now, I'm not going to lie to you. If you do this, it takes longer to machine. Okay, so you have to have that trade-off between time and quality. Okay, so if I were to set this, let's say, really low to be, let's say, 1 thou, and calculate it, this would give me a really, really nice finish. But it would take me absolutely ages to machine it. Okay, so if I delete that simulation and then simulate again, this will give me a really nice finish. Okay, now as I said before, with increasing that step over, it also means that it's going to take a lot longer to machine. So you have to find the right balance. So if I were to change that step over to what it was originally, let's say 30 thou, and then calculate, then this will machine a lot faster. And it shouldn't have that much bearing on the quality. Okay, so if I were to delete that simulation and then simulate that toolpath again, you can see that it is a little bit less quality, but it's going to machine it a lot faster. So maybe you could change that to be maybe half of that, 15 thou, and calculate that. And let's see what this looks like. So if I delete the simulation again and simulate again, you can see that that gives me a much better finish, and I'll probably get away with that. Okay, so there's a trade-off between speed and quality. Okay, so just make sure that you're aware of that. So 2 things to bear in mind: diameter of the tool and the step over of that tool. Okay, now another thing that I want to talk to you about is when you're doing the roughing. Okay, so if I delete this simulation, let's take a look at this 1/2 inch roughing. So if I simulate that toolpath, you can see that it's getting down and it's roughing out a little bit of this, and it's getting rid of most of the material. But you can see maybe in here, especially here, the smaller tool is going to come over here and plunge down into this and take off a lot of that material. Now, what you could do to avoid any problems with the finishing tool is to adjust the actual slices that roughing machines in. So if we take a look at the options there, it's slicing in 1/2 inch slices. So the step down is 1/2 inch. So if I were to change that to say 0.2 and calculate that, it would split this up into smaller slices. And you should see a more of a staggered sort of jagged effect here around the actual form. This means that there would be less issues for the smaller tool to get in there for the ball nose. Now, again, this increases time for machining. Okay, so just be aware of this. So if I were to, let's simulate just the end mill, so the roughing, and I'll just use the control bar for this. Okay, so you can see that it's done one more step. Okay, so if I increase it even more, it would do more and more steps. Now you can see that it's machined a lot of this material out that it wasn't machining beforehand. Okay, so that's the reason that you would decrease the step over. Obviously, this takes longer to machine, so just be aware of that. Right, so another thing to consider is the tool clearance strategy. Okay, now what I've been showing you is something called raster. So raster basically goes across in X, steps over in Y, comes back across in X, and so on. Now you have different strategies within Carveco Maker. The tool's clearance strategy is raster. We also have raster X and Y. So basically this goes across in X, steps over in Y, comes across in X, steps over in Y, completes the whole job, and then it sort of flips itself 90 degrees, and then it goes across in Y, steps over in X this time, comes back in Y. Now, this will give you a much better finish, but it increases the machining time twofold. Okay, so just be aware of that. Spiral basically means that it will spiral from the center and come out. Now, I tend to use this particular strategy quite a lot because I think that it gives a much better finish personally. So if I were to calculate this, I'll show you what this does. Now, the problem with doing this is if you're using something that's round, this is perfectly fine. But what it does when it does the finishing, because it's doing a box, it will come to the extremities of the box and then stop. Okay, so just be aware of that. So if I were to delete that, and then let's just simulate that toolpath quickly, and I'll use the control bar for the ball nose. So you can see this is spiraling around. Okay, and I find this gives a much better finish than doing the raster. Now, obviously, when this gets to the edges, it's going to stop and it's not going to machine correctly. Okay, so the good thing about this is that it doesn't give you those cusps in the same direction that we had before. Now you can see it's nearing the edge, and when it gets there, it's going to stop. Okay, so that's how far it's got. Now, you can see here the difference between the two machining options. Now, what's happened is, if I just close the roughing option, you've got an allowance of 0.02. So it's leaving 20 thou on for finishing. Okay, so it's leaving 20 thou of material on when it does the roughing. Okay, so that's what that line is. Now, what I'm looking at is this here. So because it's not come right the way over, it's not machining my part here. Now, to do the spiral's absolutely fine when it's a circular object that you're producing. But when it's something like this, you need to use a different option, which is spiral in a box. Okay, so this will go right to the edges. So if I calculate that, you'll see that this goes right the way to the edge. Now, the only downside with doing this is that you get a lot of air moves. So you can see all of the blue and the lighter blue are all rapid moves and plunges. So it has to jump from one side to the other. Okay, so that's the only drawback with doing this. So if I were to delete that now, and then I'll just simulate this so you can see it quickly. So you can see that it goes right the way to the edge. Okay. Right, so now what we can take a look at is the actual area to machine. Okay, so if I delete that simulation, let's say that I didn't want to machine the whole of this. So machining all of this here may be a waste of time. Let's say that I actually wanted to cut this part out. So machining all of this here would be a complete waste of time. So what we can do is two ways to do this. You've got automatic boundary or selected vectors. So to do this with selected vectors, you would need to create a boundary around it. So there's a separate video for that in the 3D design section, which is create a boundary from relief. So you would use that to machine to. You also have automatic boundary. Now this is a bit slower because it actually sorts out boundary automatically within the toolpath. So if I calculate that, it will automatically find the boundary of this relief and machine inside that. Okay, so there you can see that this is automatically just machined just the chameleon that I have there. So if I were to simulate just the roughing, and then simulate the finishing, you can see that it's just working on the chameleon. And then what I can do, I can cut the part out afterwards if I wish to do so. So let me fast forward this. Okay, so that's just machining the chameleon, ready for me to cut out afterwards. And it saves you having to machine all of the outside here, which if you're cutting the part out, let's say, it's a complete waste of time. Now, what if I wanted to just machine a section of this, let's say the head? What I can do is delete the simulation and let me take a plan view of this. And I'm just going to quickly draw a vector. Okay, so this is really, really rough. Okay, so let's say that I wanted to use that. So what I can do is, rather than automatic boundary, I can use selected vectors and then calculate. So this is going to machine within that vector. Okay, so that's how you can isolate certain parts. So if we take a look at that now, that roughs out that area, and then let's take a look at the finishing. And this just finishes within that vector. Okay, and there you can see the head within the vector that I created. So that's pretty much how you use the machine relief to machine reliefs within Carveco Maker.